So you're working in the AWS cloud, and you've got these separate private networks. How in the world do you get them to talk to each other securely without ever exposing them to the public internet? It's a classic cloud problem. Well, today, we're going to break down one of the most direct solutions for that exact challenge.
All right, so here's our game plan. We'll start with the big question. What even is VPC peering? Then we'll get into the benefits and why you'd use it. After that, we'll walk through the 4-step setup, cover the crucial limitations you absolutely have to know, and finally, we'll put it head-to-head with its bigger cousin, the Transit Gateway. So, let's kick things off. What exactly is VPC peering? I want you to think of it like a private skywalk connecting two separate buildings. It's a direct, secure path that's totally isolated from the chaos of the public street below. That's the core idea we're going to be exploring. This is the fundamental problem we're trying to solve. Picture this. You've got two distinct, totally isolated virtual private clouds, or VPCs. Maybe you're keeping your dev and production environments separate, or perhaps one VPC runs your app and another holds a shared database. How do you link them up without compromising security? And here's our answer. VPC peering. It's a networking connection that lets two VPCs route traffic back and forth using their private IP addresses. And that's the real magic right there. It makes the instances in both networks feel like they're sitting right next to each other, all on the same local network.
Let's really dig into what that means. This connection is basically a private tunnel. All the traffic runs entirely on the internal AWS backbone, which means your data never touches the risky, unpredictable public internet. This is huge. It gives you way better security and much lower latency. For the servers involved, it's just like talking to a machine down the hall.
Okay, so we've got the what down. Now let's talk about the why. I mean, why would you actually use this? What are the real-world scenarios where VPC peering is the perfect solution?
Let's take a super common example. Imagine you have a central VPC, just for shared services. Things like your logging tools or authentication services. Instead of duplicating all that stuff in every single one of your application VPCs, you can just peer them. This setup lets you share resources securely, move data fast, and still keep everything nicely separated for governance. And it's all done with a simple, direct connection.
All right, time to get our hands dirty. How do you actually set one of these things up? It's a surprisingly simple 4-step process, but there's one little step in there where almost everybody gets stuck.
So here's how it goes. First, one VPC, the requester, sends out a connection request. Second, the acceptor VPC approves it. And right at that moment, the AWS console proudly tells you the connection is active. And this is the trap. So many people stop here thinking the job is done. But an active connection doesn't actually do anything until you complete steps 3 and 4, updating the routes and the security groups.
I want you to burn this into your brain. An active connection without routes is completely useless. It's like building a brand new bridge and then putting a giant brick wall right in the middle of it. Sure, the path exists, but nothing can get across. You have to explicitly tell your networks how to use the bridge you just built. Traffic isn't going to just magically figure it out on its own. So, the most crucial part is this. You have to update the route tables on both sides of the connection. It has to be symmetrical. You see it right here. The requester's VPC needs a rule that says, hey, to get to the acceptor's IP range, send all that traffic through this peering connection. And the acceptor needs a perfectly mirrored rule pointing back. If you don't have both, you've built a one-way street to nowhere.
We've covered the what, the why, and the how. But to really master VPC peering, you have to understand what it can't do. This is where we get into the expert level stuff. So let's look at the limitations.
Seriously, if you take away only one thing from this entire explainer, let it be this next point. This is the golden rule that determines whether peering is the right tool for your job or a huge mistake waiting to happen.
And here it is, simple and direct. Peering is not transitive. So, what on earth does that actually mean in the real world?
Okay, let's walk through this. Imagine you peer VPC A with VPC B, and then you also peer VPC B with VPC C. Now your brain might logically assume, great, VPC A can now talk to VPC C by routing through the middle one, B, right? Wrong. That is absolutely not how it works. Peering is strictly point-to-point. The only way for A to reach C is if you create a third direct peering connection right between them.
And there's one other huge gotcha you need to know about. Overlapping CIDR blocks,
or IP address ranges. You simply cannot peer two VPCs that use the same internal IP addresses. It's a fundamental networking rule. If a packet is addressed to, say, 10.0.0.50, the router has no way of knowing which of the two identical networks to send it to. It's impossible. This makes planning your IP address strategy from day one absolutely critical.
So that whole non-transitive problem naturally leads us to our final section. If peering doesn't scale well, what does? This is all about choosing the right tool for your specific network design.
Let's just ask the question head-on. The non-transitive rule means that if you have, say, 10 VPCs that all need to talk to each other, you need to create and manage a complex mesh of 45 separate peering connections. That becomes a nightmare fast. So when does it actually break?
Well, the solution is to change the model entirely. On the left, you've got peering, that point-to-point model. It's great for simple one-to-one connections, but it quickly turns into a tangled mess. On the right is the hub-and-spoke model, using AWS Transit Gateway. The Transit Gateway acts as a central cloud router. You connect each VPC to it just once, and it handles all the complex transitive routing for you automatically.
So, the final takeaway is a question for you to consider for your own architecture. VPC peering is a fantastic, simple, and secure tool for connecting a handful of networks. But as your cloud environment grows, you have to ask yourself, is my network simple enough for these point-to-point connections, or is it time to graduate to a central transit hub? Knowing the answer is the key to building a truly scalable and manageable cloud network.